Hello and welcome back. These will be the notes for 7.5, Solving Special Types of Systems. There is a PDF if you'd like to print it out. And first type of special system, we can see here we have two equations that have been graphed, and it appears that those two lines are parallel to each other. So if there's no point of intersection, there's no solution to the system. Now we can go ahead and solve this and try using elimination here. So we're going to go ahead and subtract these, and you'll see that we end up with 0 plus 0 equals 0 equals 8. And we know that that is not true. So anytime your variables drop out of the problem, we got to check to see if it's true or false. Well, this is false. That means there is no solution. Now we can call this a parallel system, or we can call it an inconsistent system. Next one here appears to be only one line, but there's actually two lines that are just on top of each other. We refer to this as a dependent system. And this ends up having infinite solutions. And if we solve that with one of our methods of solving systems, let's say we use substitution. So in place of y here, we're going to substitute all of this, so we end up with x minus 2 times 1/2 x plus 2 is equal to -4. Then we're going to distribute the 2, so we have x, that's going to be a -1x, and that will be a -4 is equal to -4. So combine my x's, x minus x is 0. 0 minus 4 equals -4, so -4 equals -4. So you can see my variables dropped out of the problem, and what was left over was true. So we end up with a dependent system which has infinite solutions. So how many solutions? Well, if we have the same slope with a different y-intercept, no solutions because the lines are parallel. If we have the same slope and the same y-intercept, we have infinite solutions because it is the same line. If we see that we just have different slopes, then there's only one solution. Two lines that intersect once. That's what creates one solution. Okay, so how can I tell how many solutions we have here? Well, I'm going to rewrite these in slope-intercept. So the first one here is going to become 3y is equal to -5x plus 6. Y is equal to -5/3 x plus 2. And then I'll do the next one here. I have a -3y is equal to 5x plus 3, and then divide by -3, y equals -5/3 x minus 1. That's this one. So if we look at the slopes here, the slopes for both of them are the same, but the y-intercepts are different, so that means that these lines are parallel. No solution. Now, if you know the shortcut for finding the slope and the y-intercept from standard form, you can do those. Over here, I'm going to rewrite it. First one's already done. The second one will be 3y is equal to 6x minus 12. Y is equal to 2x minus 4. And here we can see that we have the same slope and the same y-intercept. These are the same lines, which creates infinite solutions. Here's just another visual aid. I think we put this in a previous lesson on what one solution, no solution, infinitely many solutions would look like. Two lines that intersect, two lines that are parallel, or two lines that are exactly the same line. Match the graph to the equation. So all I'm going to do is find the slope and the y-intercept. Slope of the first one is going to be -1 over -3. I don't care about this y-intercept right now. The slope of the second one is going to be -1 over 1. Well, these two slopes are different, which means there's one solution. So if I look at points A, B, and C, or graphs A, B, and C, there's only one here that has one solution. It's that one, letter B. Go on to the number 6. I have a negative 1 over negative 1 slope for the first one. I have a 3 over 3 for the second one. So both of these slopes are equal to 1. The only question is, are they the same line or are they parallel lines? The y-intercept of the first one is going to be negative 4 over negative 1, which is 4, and the y-intercept for the second one is going to be 2 over 3. So the slopes are different, which makes them parallel to each other. So this one would have to be C. And then by default, A has to match 7, which means they have to have the same slope and the same y-intercept. Let's just double check that. So I have a negative 1/3 for the first slope. I have a 2 over negative 6, which is still a 1/3. Okay, the y-intercept of the first one is going to be a negative 1 over 3, and the second one's negative 2 over 6, which gives me the same slope and the same y-intercept. So they are the same line. How many solutions? So we're going to be looking for 1, none, or infinite. Okay, I'm going to go ahead and solve for the slope and the y-intercept of both. Slope and the y-intercept of both. Okay, so the first one has a slope of negative 1 over 1 and a y-intercept of negative 2 over 1. And the second one has a slope of negative 1 and a y-intercept of 5. So these have same slopes but different intercepts, which means no solution for the first one. Okay, calculate M and B. M and B for the second one. So M on the first one's negative 3 over negative 4. And it looks like I have a 3 over 4 for the second one. The y-intercept of the first one is going to be 12 over negative 4. And the y-intercept of the next one is going to be negative 3. Oh, I didn't have to go that far. So as soon as I saw those slopes are the same, I look at the y-intercept and I see that this is actually equal to negative 3 also. So I have the same slope and the same y-intercept for both, which makes it the same line, which means I actually have infinite solutions. And the last one, so the slope of the first one is going to be negative 3 over negative 1. The slope of the second one is going to be negative 3 over 5. And I actually can stop right there because my slopes are not the same. As soon as my slopes are not the same, then I know that I have only one solution.